Good afternoon and welcome to Lesson 5 of our Flipped Scientific Method unit on data analysis. So we're going to talk about the different types of data and how you can organize your data. So you should have your data analysis notes handout ready to fill in the blanks as we go along. First, we need to know what are the two types of data. There are two different types of data. There's quantitative data, which sounds like quantity, which means how many. So that kind of data is uses numbers and measurements. Okay. Then there's qualitative data that's descriptive. It uses words, and it sounds like quality. So, all right. Our examples. Here's our first one. A drawing of your M&M dissolving. Do you think that would be quantitative or qualitative? I'll give you a few seconds. If you said it was qualitative, then good job. It's qualitative data because there's no numbers involved and it's actually just a picture. All right, next example. Timing how fast your M&M dissolves. Okay, if you wrote quantitative, nice job because you're actually going to count the number of seconds it takes your, or minutes it takes your M&M to dissolve. All right, they're pretty straightforward. If you can remember quality and qualitative and quantity and quantitative, that will help you keep those two words from getting mixed up. All right, so how do you organize your data? You can put it into a chart or a table. Some people use those words interchangeably. I like to just say table. And then you can graph it. First, you should always put it into a table to keep it nice and organized so you're not writing random numbers all over your page and you don't remember what they're for. And then after it's in your table, you can use that to easily graph your data. So how do you use charts and tables and graphs? Well, they help you organize your data. Then they help you identify patterns in your data, like if your numbers are increasing or decreasing or staying the same. And they also help you present your data to support or falsify your hypothesis. So support or reject your hypothesis. A nice table and graph can help you easily show someone, see the trend is going up or the trend is going down, it's decreasing. So it's pretty straightforward. But there are some rules for when you create a table. You need to make sure each column and row is labeled with a title. I need to know what that row and column are for. You also need to make sure it has a title. This is probably the most missed point on lab reports, is giving the table a title. And it just can't be data table. It has to tell me what the data is about. And it should always include the unit somewhere. So what were you measuring in? Were you measuring in meters, centimeters, inches, seconds, minutes, hours? So we need to make sure the units are somewhere in the table. So here's an example of a well-done table. You see it has a title at the top that says type of candy and dissolving time in water. So I know exactly what I'm going to find in this table. So we have a type of candy. Over here, M&M's and peanut. M&M's, you can see they're labeled. And then across the top, the columns are labeled for trial 1, trial 2, and trial 3, and then an average at the end. And you can see the units are in here. All right. So, after you put it into a table, then you can graph it. Okay, there are 3 types of graphs we use in 7th grade. A bar graph we use for comparison, and you've done these all in math class before, maybe not in science, but in math you have, where you draw the bar to how tall the number is over on the other side. And then a line graph to show a pattern, if we're looking to see if things go up or down. And then a pie graph to show percentages, where they have pieces of a circle. So mostly in 7th grade we'll use a line graph or a bar graph. We don't use pie graphs that much, but we do practice reading them. All right, so just like there's rules for a table, there are rules for a graph. You need to make sure your graph has a title. You need to make sure you choose the correct type of graph. So if we're comparing two things, you're going to use a bar graph. If we're looking at a change over time or a pattern, we're going to use a line graph. And if we're working with percentages, a pie graph would come in handy. You need to make sure the axis, the y and the x-axis, are labeled. You need to make sure you put units on them. So you need to put, dissolving time, seconds, type of M&M across the bottom. So you need to make sure they're both labeled. Identify the independent and dependent variable. The independent variable always goes across the x-axis, and the dependent variable always goes across the y-axis. Let me see it. Get a pen here. It always goes across the x-axis, and this one always goes across the y. Okay? So let's look at this. Let's draw a little graph over here. Oop, that's kind of crooked. All right. So the independent variable is going to go across the x-axis. So in our experiment that we just looked at, peanut M&Ms and then regular M&Ms were our two, and they go across the bottom. And then up the side we put our dependent variable, which was time. And we got to make sure we put our units, and it was we measured in seconds. And then our title would go across the top up here, and then we would put in our bars because we're comparing two types of M&Ms. Okay, and choose an appropriate scale. Well, if our seconds never go above 60 seconds, then we don't need our scale to go all the way up to 300 seconds. So you need to space it out and use the whole axis, and then include a key if you need it. This one doesn't really need a key because we only have two different things, but if you're comparing a bunch of things or you have a bunch of lines on your graph, you might want to put a key down in the bottom to help people figure out your graph. All right. So here's some examples. Let's try this. Which type of graph would you use to show the change in temperature over a month for a city? So we're looking at change in temperature over a month. I'll give you a couple seconds. Choose between a bar graph, a line graph, or a pie graph. If you chose a line graph, you're correct because we're looking at a pattern over time to see how the temperature changed. Okay, let's try this one. Which type of graph would you use to show the number of students who like each type of pop? So we're looking at students who like the number of students who like each type of pop. And if you chose a bar graph, you're right because we're comparing the number of students that like each pop. Okay, which type of graph would you use to show the percentage of students who earn each letter grade on the last test? So percentage of students. And if you chose a pie graph, you're right because you're displaying the percentage of students. Good job. All right. And that is the end of our handout for today, our notes for today. So come to class tomorrow. We're going to practice making some graphs with some quick gummy bear experiment. It'll be a lot of fun. So make sure you're ready to do that and take your entrance slip, and I'll see you tomorrow.